Today I am discussing the first one only again, okay? Because like last day, since surface plane analysis, this is completely new to us. So after last day, I found that you were still not comfortable with the analysis. So today we will do it even in an easier manner, and we will also plot on the board so that it becomes convenient to you, okay? So let's see. So that's why I am writing everything step by step. Now the fourth one, how could you get that? These two, like it is like a very common, right? Because from that this Z means Z1 and Z2. Now this A bar is the transform version, that is after diagonalization. This P is the diagonalizing matrix. So where there is mostly we will have these three cases with some sub cases, right? So mostly these three structures. So we can even name it. 1, 2, this one, 3. Okay. So the first case isn't like under that we can have some sub cases, but anyway, there is here. If you see, this is my assumption. It can be readily the reverse as well. Okay. So from that, what already we have is here. If you write that is Z1 dot equals to lambda 1 Z1, right? And then Z2 dot equals to lambda 2 Z2. Now from that, this one, the third one, we already derived last day, right? So this is known to all of you. The fourth one, like dz2, this is the z2 dot means dz2 dt, and this is dz1 d1. So from that, what will be the relation? Simply it would be lambda 2 z2 by lambda 1 z1, right? Now z2, if you replace or if you substitute this expression here, then what would happen? C lambda 2 by lambda 1, and then z2, here you have z1 to the power this, and here already you have 1 z1 at the denominator. So ultimately it would be z1 to the power lambda 2 by lambda 1 minus 1. This will be the whole power, right? And this I am denoting by equation 4. These 4 equations will be required for analyzing or for drawing the phase plane plot for all the 3 cases, right? If you have even 1% doubt, please feel free to ask. At this moment, that is, we are learning the case of real distinct eigenvalues and they are negative, okay? Because if we can draw that pattern, then anyway, that is, we can even consider the unstable case. I mean, if both of them are positive, then simply you have already seen the plot, that is, if both of them are negative, then it would be a stable node. That means it will have a converging characteristic, okay? So if we know how to draw that one and the pattern why this is coming converging, then easily in the diverging case, we could have swapped the arrow and the pattern will remain the same because none of the equation will change, okay? So at this moment, then I think that is you had a doubt, that is in the 4th quadrant plot, if the initial condition, suppose first on the 1st quadrant, then on the 2nd quadrant, 3rd quadrant, so how we can resolve those cases, right? Because probably that is I only showed for the 1st quadrant, that's why there is you might face some difficulties, but today that is we will learn that is in each of the quadrant, okay? So this is my phase plane. This is called phase plane in the modal coordinates. Why modal coordinates? Because after diagonalization, that is this representation, this diagonalized version, this is also called the modal representation. Why? Because e to the power lambda 1t, e to the power lambda 2t, they are the modes of the system, right? E to the power lambda 1t as well as e to the power lambda 2t, they are the modes of the system. What do you mean by modes? Like, modes means, suppose this z, ultimately the expression, whether it is z1 or z2, we will always be right in the form of, here at this moment z1 equals to, already you have seen, that is here 1 and 2. But this one, that is if we wish to write, why do you need the modes? Then x1t will also be c1 e to the power lambda 1t plus c2 e to the power lambda 2 in near combination of those two exponentials. Okay, in that way, for any kind of system, c3 e to the power lambda 1t plus c4 e to the power lambda 2t. In that way, it is once the modes of a system are known, then its responses will be the linear combination of the modes. Okay, so that's why the modes are really important for any dynamic system. Here, that is C1, C2, C3, C4, they are all real numbers. Okay, and constants. So these are the ability of modes. Now that is the reason why this Z2 and Z1, they are not the original coordinates, right? They are after the diagonalization. So that's why in the Z coordinate, there is no dependency. It is simply that is Z1 dot equals to lambda 1 Z1, no dependency on Z2. Here also, no dependency upon Z1. So that it is completely diagonal or decoupled. That is the reason why they are called modal coordinate system. Okay. So the phase plane analysis, why we are doing with respect to the modal coordinate, because this is easier. Once you draw that one, then after that, if you transform the system or this entire drawing back to the original coordinate x1, x2, then it would be the real one. Or rather, I should not say the real one with respect to the original coordinate, because here this is the relation. So x equals to pz, or even like z equals to p inverse x. So once you have z, then after that you can easily get back to the x coordinate. Then it would be with respect to the original coordinate. Okay. But it is always like much easier to draw the phase plane plots with respect to the modal coordinates. Why? Because it is completely decoupled, no interdependency. Okay, that is the reason. So then, like first of all, this is my z0. Both of them, like z1 0, z2 0, both of them are positive. And not only that, that is today we will learn that is wherever maybe the initial condition, any of the quadrants, how we can draw it. So, like last day, I believe that is I mentioned that is the shape would be somewhat like that. And for that I gave you some with respect to some numerical data. I showed you that is the Z2, it can be Z1 square, Z1 cube, Z1 to the power 4. And at the same time, if this relationship is reversed, that means depending upon the lambda 2 by lambda 1, then it could have been Z2 equals to Z1 to the power half, 1/3, 1/4 like that. Okay. So today we will learn it again, and that too in a easier manner. Let's see. this moment, that is choice 1. This is just for my convenience, okay? Because like I am about to draw some numerical values, so that's why I am using only very convenient real numbers, okay? But you can try with respect to any other values. So if both of them is 1, then it will give you that is c equals to 1. It will give c equals to 1. Then after that we have to get the pattern. So if c equals to 1, and also it will give you z2 equals to z1 square. Right? Now it can be other things, that is if I consider this lambda 2 to be like 3 or 4, then accordingly this power will also change. Now that is you will have, like while drawing the face plane, you will have two questions. One is the shape, okay, and then the sign. That is one second. That is when you were drawing, like this is the initial condition, fine, like both of them are positive. Like one is the shape of the locus, right? Another one is the values, or especially the sign. So one is the value, another one is the sign, okay? Because like whatever it is, if it is something like this, or whether this is something like that, or this, or these are different type of shapes. So one is the shape which will come with respect to the values, and another one, this is the sign, that is whether it would be entirely in the first quadrant or some part will go into the second, third or fourth quadrant, right? So for drawing the locus, we need the pattern and in the values, and then its sign, okay? So that is, if you have to draw from scratch, that is, let's draw it numerically. After that you will find, that is, last day I already said, that is, if it is like a parabola, that is as if y equals to x square. Okay, so from that, when I drew it, still you had a doubt, because here, like when we draw y equals to x square, then none of them is a variable of another quantity. So that's why when we draw a parabola, hyperbola or ellipse, we don't face that much difficulty. But now the problem is that the z2, that is a variable of time, z1, that is also a variable of time. So of course it's a parabolic relationship between z2 and this one, but while drawing you have to be really careful about the original values of z1, because that z1 is a solution to a differential equation. So that's why drawing the face plane pattern is not that easy. Once again, what did I say? That is z2 equals to z1 square. This is not a big deal. This is just like a parabola, y equals to x square. But while we learned drawing parabola, hyperbola or any of the conic sections, they were not dependent upon any other variable. But now you see both of them, they are functions. Is z2 and z1, although that is it gives the parabolic relationship, but individually they are solutions to two different differential equations, right? So at this moment, that is z2, we are not bothered about this original solution to the differential equation, at least while drawing the locus, because we have already obtained a parabolic relationship. But here z1 is the independent variable, that is when you are drawing this locus. So z2 is the dependent variable, z1 is the independent variable. But is the z1 like 0.1, 0.2, 0.3, something like that? No, because Z1 is a solution to a differential equation. So the value of Z1 will be governed by equation 1. Okay, so that's why there lies the trick, or there lies the little bit problem. That is when you draw, that is at the same time, that is whether starting from here, it will come this side, or this side. That we don't know. Like last day, exactly the doubt that you have. Once again, that is starting from this point, whether it will come this side, or this side, or this side. That we don't know. That either you have to decide analytically, I mean mathematically, or simply that is you can prepare a table with respect to the numerical values and then you draw. So today we will learn both, so that is your basic becomes stronger. So that is this one, it will give you shape of the display trajectory. So this relationship will give you the shape of the trajectory, okay? And then for drawing, how would you find the values of Z1? The values of Z1 you will have to get from equation 1. With these two guidelines, we would be able to draw the graph. Okay. So of course, that is we will prepare a table. But before that, if somebody asks me, that is, sir, how can we draw it without having a table? Okay. So let's see. That is at this moment, that is we can use. It is if we know the slope, then we would be able to draw the locus, right? So you see this dz2 by dz1. That will denote the slope, isn't it? Slope of the first plane trajectory. Okay. So at this point it is C into delta 2 by delta 1 into Z1, right? C, this is 1, right? Delta 2 by delta 1, that is also 1. And then my Z1, again it is 2 minus 1, so 1, right? So it is simply, no, lambda 2, that is already, that is we have assumed here. So that will be 1, so it will be only Z2, right? Or is it? 2Z.
So could we directly differentiate the shape of the trajectory to get this?
At this moment it is continuous, so that's why not only continuous, that is absolutely continuous. So that's why we can do it. Okay, but not in all cases, but at least for LTI systems, all the phase plane trajectories, they are continuous. There is no break. That's why we can do it. Okay. So 2Z1, it is fine. And then that is, if you see, that is the slope, right? And Z1, that I already said that those values you will have to get from the solution. Now that is overall what we can see. This is Z1, it is fine. And then that is, if you see the value of Z1, then what is the value of Z1? Isn't it? Z1t, it goes to 0 as t tends to infinity, because here the lambda 1, that is minus 1, or even whatever other values you pick up, but this is the case where lambda 2 and lambda 1, both of them are negative, right? So from that is what we know.
So it will be 0 and t equals to.
Exactly. That is initially the value that will be like the finite, of course, because at the beginning, if you see the starting value, it would be exactly 1, right? Because z1 0 that we have considered 1. So dz2 is goes to 0 as this we can write. And individually, if someone wants to see that is what is the plot of z1, in our case it is simply e to the power minus t. Okay. So the slope, that is, it will continuously take up the values like this. So if you see, that is last day, that is I drew the pattern, this one. At this moment we only know that it's a parabola, right? So if this is the point, so from that, suppose that is if we tend to draw this one, then we have to check whether this matches with this data or not. So does it match? Yes, you see, that is if this is the z0, then starting from that is when that is z1 tends to 0. Here z1 is positive, so that's why mod of z1 and plus z1 is exactly the same. When z1 goes to 0, then the slope also goes to 0. Initially, the slope is quite high, or rather, my drawing is not exactly something like that. Isn't it? Like initially the slope is high, then continuously the slope is getting reduced. Already, that is if you ask me, sir, how to draw, I will show you the easiest way, that will come from table, I mean simply the locus plotting, that is a separate thing, but analytically how could you draw? First of all, you have a big backup about the shape from this relationship, z2 equals to z1 square, so you have a parabola, right? Now after that, even like last day itself, that is we learned that it's a parabola. The question was that whether this goes this side or this side or this side, in which direction. So for that we have to obtain the values of z1, that is how does z1 vary, right? Now this is the variation of z1. So this is an exponential relationship. It will start from z1 0. At this moment z1 0, that value is 1. So then if it is exponential relationship, then gradually from 1, then like 0.99, 0.98, 0.9, 0.8, 0.7. In that way, the values will continuously, that is, they will take towards the 0. Just it is an exponential relationship. And now here, at the same time, what will happen? That is, suppose if it starts from 1, then 1 square, after that 0.9 square, then 0.8 square, 0.7 square, so on and so forth. If you plot those values, then how would you think? That is, how would be the shape? It's a parabola, of course, but how will be the pattern? Whether it will go up or go down. Since z1 is getting reduced continuously, so of course it will go down, right? So that is the reason why I chose this one, not this one. That is the first thing. Is it clear to all of you? That is why I chose that it should go down. Okay, because the z1 here, both the modes or both the eigenvalues are negative. So the z1 of t, the z1 value, this is continuously decreasing starting from z10. So whatever may be the position z0, that means this is your z10, this is your z20. So starting from z10, all the remaining z1 square, they must be at the left hand side compared to z10, because the absolute value of z1, here everything is positive, so this is continuously decreasing. Okay, so first you see that is how we can, that's why there is again and again I am saying, obtain the values of z1 from equation 1. Now see, in this case it is relatively simpler. Why? Because z1 is completely positive. But if you have an initial condition here when z1 is negative, there how can you find? Again from the same equation, like I will come to that, don't worry. That is at this moment, that is like if you see the z1 from equation 1, if z1 0, if that one is positive, then the whole z1 will be positive. This is a very important point, please remember. If z1, because whether lambda is positive or negative, e to the power lambda t, it cannot be negative, right? So this solution, this value z1, if z10 is positive, then z1t will remain positive for all t greater than equals to 0. Similarly, if this is negative, then z1t will remain negative for all t greater than equals to 0. So in this way, that is you can assure, or that is you can be confident about the sign of the values of z1 from this equation. And then once it is done, then after that you come back to this z2. Now you can ask, that is, sir, here for simplicity you have assumed c equals to 1, and then that is like the other things also. Suppose in this case you had another one, lambda 2 by lambda 1. So if in a general case, if because the expression of c is this one, then how to find out, that is, whether z2 will remain positive or negative, or they will have different values? Again, you check this one, z2. That is the advantage of drawing the plot in the modal coordinate. Here also the same thing. Whatever may be the variation of z1, because I am saying with respect to, at this moment it is square. So whether z1 is positive or negative, it will always be square. But if this one is -3, and then if this one is z2 equals to z1 to the power q, immediately you will have a confusion. If z1 is positive, then z2 will be positive, fine. But if z1 is negative, are you getting my query? That is, at this moment it's a square. So whether z1 is positive or negative, you don't have any doubt. But if you have the cubic relationship, then the value of z, you cannot readily say z2 will always be positive from this relationship, because here if z1 is negative, it will be negative. So then how to judge the sign of z2? Again you have to come back to here. Here also you see, that is, whatever, if z20 is positive, then z2 will remain positive for all t greater than equals to 0. Isn't it? You can say, that is, sir, we are not becoming confident, because when you obtain this relationship, this one, z2 equals to c into here, if we have to find out the, if you have to find out the sign of z2, then we have to check the sign of c, and then the ratio lambda 2 by lambda 1, that is fine. But everything like this relationship, they have been, like, it is derived based on 1 and 2 only, right? Wait, that is this, once again, this 3 here, you like might have just got a doubt that this c, that is, if you have to obtain the sign of z2, then that is, you should be knowing the sign of c, and then you see in the c, z2, z20, z10, both of them are there, and not only z0, again z0 to the power lambda 2 by lambda 1. So then that is, you may fall into a loop. So please don't do that. If you have to like find out the sign of Z1 and Z2, always you check these two equations, okay? And for both of them, you have the same logic. If the initial condition is positive, then the solution, it will remain positive for all t greater than equals to 0, isn't it? Why? Because you are doing this analysis in the modal coordinates. You don't have any dependency upon the other variable. Z1, it is completely decided by Z1 0. Z2, it is completely decided by Z2 0. Okay? But this is not possible if it is not possible in the original x2 and x2 coordinate, because there both the modes are associated. So that is both the differentials are there in both the equations, right? So I hope you have understood what did I mean to say. Then that is starting from Z0, at least it is not going upward, that is like sure for all of us. Then that is, so the values are continuously coming down, that we have understood, okay? So starting from this point, that is here, it will approach towards the origin, we do not have any doubt, right? And before that we have already got the shape will also be a parabola, okay? Now that is, if you have a doubt whether this is something like this or like that, for that already I said, that is, if it is square cubic, then with respect to this point, this is either this one or this one or this one, or if it is half, 1/3, 1/4, then it would be like this would be like this is like this, right? But suppose you are even not sure about that, so let's make a table which is the easiest. Like if you see these plots using MATLAB, then MATLAB will also do the same thing, that is that plotting any locus, that means first we'll have to prepare a table about the values of the x variable, y variable, and simply we'll have to plot. So let's see what do we get. So here, please help me to, with respect to this data, if I first write Z1 and then Z1 square, Z1 cube, Z1 to the power half, Z1 to the power 1/3. Okay. So I request all of you to use your mobile to get a calculator, okay? Because we will be needing that value. So starting from, that is Z1, so at t0 it would be Z10, which is 1. So this will be 1, this will be 1, this will be 1, this will be 1. So we don't have any problem. And after that, at t1, suppose this is 0.9. So what I want to see, or what I want to prepare, in this way we will prepare the table, okay? You please help me to find out the values. It is 8, 1, 6, 4, 6. Can you tell me the values? Ashutosh? That is 1 by 1. This one, that is the cube, 0.9 cube. 1
79.
1 point.
0.79.
And then after that,
0.5.
little louder please.
0.512. 0.343.
0.340. Then for 0.6 whole cube.
.216.
Then 0.5.
0.125. 125. 125. 0.0646. 0.046.
0.0
664.
or 0.3,
0.027.
0.027. That is first set of values will be fine. Then this one, they will also be required, right? Because we need to figure out both this part and this part, like both the shapes. So now that is we need the square root values. So square root 0.9,
0.9487.
0.9487. Then
0.8944.
8944. Then 0.7 root
0.8366.
83.
66.
After that 7746 or 7046. It is root 0.6, right?
7746.
After that root over 0.5.
0.7071.
Root over 0.4.
0.6325.
0.6325. Okay, that is fine. And then for cube root of 0.9.
0.9655.
0.96. Then cube root of 0.8.
0.9283.
Then cube root of 0.7.
0.8870.
Then
0.8434.
after that
0.7937.
then
0.7368.
fine. Thank you. Let's try to plot. So they are all the values of Z2, right? Now for it is 1, right? Then for 0.9 it would be 0.81. So here if you see 1, 2, 3, 4, 6, 8. Something like this. Then after that for 0.8 this is 0.64. So here if I mark 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8. And actually it should have been like even higher, but I don't have space over here. Really sorry about that. But let's see. That is, then you should think that is as if the point is here. Okay, although that is beyond the board, but anyway, that is now for 0.8 it would be 0.64. 0.64 means almost would be from here. Isn't it? Now for 0.7, 0.49. 49 means almost it is. After that, for 0.6, it is 136. Then for 0.5, it is 0.25. For 0.4, it is 1.6. For 0.3, 0.09. If you go further down for like 0.2, it would be 0.04. If you join the locus, then can you see the parabolic nature? Now that is, you plot, this is fine, we have already seen. I hope now like you, all of you are confident that is why the locus is coming down, right? That is why the motion is this side, right? Now that is, it will be really important for us to plot this one and this one, because that is, we have a doubt that is why it should not follow the upper way around, okay? That is which I said it would be for the square root relationship, but we have to plot. So then that is, could you please plot the other three in your, that is, graph. Here I will also plot, let's see. You also do it separately, okay? Best is there is many online graph plotting softwares like Zooplot and other things. If you use, that is readily you can see the values. So basically here the concept, like let me see, it is 0.729. can you see? This is the graph for this line. This is 0.729, and after that 0.512, then 0.340, 0.216, all of them. So this one, this is for Z12, and other one. For these two, I hope all of you are confident, because like really I could plot them, but regarding the other ones, I really don't have space here. So if you plot the other ones, I'm sure you would find that this will come like this. I believe they will be something like that. Faz, you had a question, please ask.
So, like for example, few cases, like if my initial condition, let us suppose in this case is -1.
I'm coming to that. This is so that's why I said that is if all of them are positive, then readily we can draw. But now suppose if they are the other for other type of initial conditions, that we will do now itself. Is it now fine for all of you, at least for the first quadrant? Okay, good. Now that is, I will erase this side and draw the other one. Okay. If this is now the situation, then what would happen? That is, we have the same relationship, that is not a problem. Right. Now here, that is, do you remember that is a few minutes back I was talking about this doubt. Now, suppose at this moment, that is, if someone asks you that what will be the sign of Z2 and that too over the entire interval, what would you say? then that is you will have a doubt, my C equals to this one, then that is like readily, that is what we are tempted to do, that is putting the values of Z20 and Z10 and then checking that is how it is going to be, right? But you don't have to do that. Again, that is, as I said, that is you readily check, you come back to the different solution of the differential equations, then you see what will be the values. Like whatever may be the C and the other things, that is Z2, you see here Z0, Z20 I have considered plus 1. Can Z2 be ever negative, at least for this case? Please think about that. That is this relation Z2 equals to C into Z1 to the power lambda 2 by lambda 1. This we have derived based on equations 1 and 2, right? So they are the fundamental ones because they are the solutions to the differential equations what we already had. Now if Z20 is plus 1, then e to the power lambda 2t, whether lambda 2 is minus or plus, the e to the power lambda t, it cannot ever be negative. So the sign of Z2t, that will be completely governed by the sign of its initial condition Z20, right? So here Z201, that will imply that Z2t, that will be greater than 0 for all t greater than equals to 0. Isn't it? See here I didn't write greater than equals to. Why didn't I write greater than equals to? Because we know that is finally, that is it will be 0. Why didn't I write?
So it will tend to 0, but never be equal.
Exactly. So here that is if I write greater than equals to 0, that means that is if I have to show that is yes, Z2 will after some time, or that I don't know that is after how much time, but if I have to show that is Z2 will attain 0 value, then here I cannot simply write for all t greater than equals to 0, because the meaning of this one is that whatever may be the high value of t, they will still be a real number. Z2 of t, that will be 0 if I like substitute t by infinity. That means that is here when I write that is limit t tends to 0, or in this case no, really it will e to the power minus, like when you write lambda t, so lambda infinity, that is actually 0, right? So for that, here that is I have to write t equals to infinity, but that is not included. When you write for all t greater than equals to, that means this t belongs to, that is r greater than equals to 0, or some, well, this is same as in different books or papers they write r plus. That is for all real numbers, then starting from 0, okay? So this real number line r or c, or even when we write r or r plus whatever, this is excluding infinity. So that's why in this case, if I write only for all t greater than equals to 0, here certainly I cannot include the 0 value of Z2 because the t infinity is not included. And then similarly, Z1t, that will also, it will be negative for all t greater than equals to 0, isn't it? Again, from this equation, for the same reason, okay? You can say that is from here, that is ultimately whatever may be the relationship, whatever may be the sign of C and the other things, at this moment here it is Z1 square, so the situation is still favorable because all the negative values, they would be squared and they will become plus, but easily it could have been C Z1 to the power q, I mean all odd powers, because if it is minus 3, right? In that case, definitely you will have even more doubt. if you wish to find out the sign of Z2 depending upon this relation, that is one, like many times I said, once again I am repeating, that is if we have to decide the sign of Z2 from this relation, you will have several doubts. Number one, what is the sign of C? Then you have to get, first of all, you have to derive the sign of C from its original, the C expression, and then what will be the sign of Z1 to the power. Because if it is even power, of course it will be always positive. But if it is odd power, then it would be negative, right? For negative values of Z1. So that's why that is so many things are related. So first of all, the sign of C, and then the values of Z1, and then its power. But ultimately, that's what I said. You don't have to go into like those many intricacies. Rather, you directly that is focus on these two fundamental relationships, and immediately that is you can chalk out. Okay? So that is for, so then once again that is I say, that is then what is the requirement of this equation to decide the shape of the locus? Because if you don't know the shape of the locus, then every time you have to prepare this table. That is, if you go for the numerical plotting, then every time you have to prepare this table, and then from that you will get to know the shape. But if you have, because all of you have your like natural intelligence, and you have the mathematical common sense, from that is if you know the equation, that is the relationship between these two variables, then you don't have to like draw this pattern, right? That is the utility of that relationship. Is this fine? So let's see. That is what happens. Now that is starting from, suppose here, then what will be the values? Then if it is Z1, it's 0, yes. Here I should draw the, sorry. Isn't it? This is Z1 versus T. If you see, that is the initially I made a mistake, that is I drew this one. Why it is not correct? Because this is also the same relationship but for the negative time. Earlier, that is when I drew this one, e to the power minus t, of course, and the time is increasing. Now, that is here what I am drawing, that is 1 is e to the power minus t, and then at this moment that is what I am drawing, that is minus e to the power minus t versus
So e to the power t. So this one was e to the power t.
which one?
Sir, that one you drew a mistake.
This one?
This one.
Huh. But here it is still decaying relationship, right? That is as if for the anticausal system. So this is e to the power minus t. This is also you say that this is e to the power plus t. But why this is plus t? Because usually if you write e to the power plus t, then don't we get this relationship? That is for e to the power plus t.
So, but if we do minus of e to the power minus t, then it will just
No,
keep
no,
on
no.
down.
It's a minus this one. That is, this is actually that is minus e to the power minus. So I am coming to that. That is here we in the first initial condition. This is the case when for z10 equals to plus 1. This is for z10 equals to minus 1, right? So what I said, that is initially, this is for e to the power minus t, right? Starting from 1. This is the first case. Here, what I wanted to say, that is initially by mistake I drew this one. But why it is not this one actually, this should be this one. Why? Because t is counted in the positive direction, right? So that's why that is e to the power minus t and then z10 minus 1. So it should start from minus 1. So starting from minus 1, it is going like that. So this is the graph for minus e to the power minus t. Now what about this one? Is this e to the power plus t? If t is increasing, then it is this one. And so you said that this is also e to the power plus t, provided that is t is decreasing, right? So here that is you either become, but if you write that e to the power plus t, then that is it can cause a trouble. Usually what we write minus e to the power, sorry, that is e to the power. Here all the values. This is usually with respect to another t variable like t dot or t dash.
So this is, I think, hyperbolic graphs. We cannot draw this graph.
Exactly.
Each
That is when we actually draw. This is one part is this, another part is this. That is one for t positive, one for t negative. Okay, you are right. So, but we should not call it a e to the power t, because if you say e to the power t, that is a like growing graph. So that would be like this. Okay. Now for this one, what will be my z2? Try to get the values. This is z2, this is z1, and my initial condition is somewhat like this. Then in this case, what will happen? That is, now all these values are negative, but z1 square, all of them would be positive. So can't we draw them? Let's see. That is, it will start from, what is the first value? Minus 1. So this is with respect to minus 1, this is plus 1, right? Then with respect to minus 0.9, plus 0.81, right? then with respect to minus 0.8 it is plus 0.64. 0.76. Six four.